less if you want to, because this capacitor is already 10 nanofarads, so the series capacitor is what actually defines the frequency of the range of the oscillation. And now, as you notice already, what is the bad part about this the use of the capacitors as frequency variable in VFOs to convert them into VCOs instead of the varicaps, is that these capacitors do not only change their voltage, do not only change the capacitance dependent on the voltage that is applied to them, but they also change their capacitance dependent on the temperature variations. And usually when these capacitors are able to change their capacitance by an applied voltage match, they usually also change their capacitance very much with little temperature variations. So that's why you hear now that the oscillator is not stable at all, where it should be very stable, very accurate, very stable on when using a simple airspace variable capacitor. You notice how unstable it is? The final thing I have to say is that this little red capacitor here is probably a Y5V capacitor, a Y5V type capacitor, and these are probably these have probably the best, the largest instability. So this can be used the best for changing the frequency of the oscillator. However, as I said, they have terrible temperature coefficients. You can use also X7R capacitors in place with a little bit decreased range. And also noticed that the companies, when they define the capacitor to be X5V, for example, you don't really know what ceramic is inside the capacitor, but the type is defined by the characteristics of the capacitor, the characteristics of the temperature coefficients, for example. So have in mind that. That's why you also can see many differences even from a same value capacitor from different companies. So yes, if you don't have a varicap, or in circuits that do not allow varicaps to be used in them, such as my mini VFO, which is a Franklin oscillator, you could use fixed capacitors in this configuration, but you have to combine them with a phase lock loop, or a frequency or other frequency stabilized circuits, really to make a stable oscillator. So this was an interesting experiment, but in this configuration it's almost unusable, I would say, for RF use. However, this oscillator, where I got the idea of these capacitors used in this configuration, is an audio oscillator, an audio voltage controlled oscillator, and in the audio range it might be more suitable to do it that way. After all, I am not aware of a VCO for audio, at least that simple, at least one that uses a varicap, because varicaps have very low capacitances range. So it might be usable as an audio oscillator. I haven't built the circuit, so I don't know exactly about its performance, how stable it stays on frequency, but it might be useful on audio. It would be interesting to try it in future. So thank you all for watching. Here is Costas, Sierra Victor 3,